In residential electrical systems, a readily accessible disconnect rated not less than the service amperage is required for each service disconnecting means at the building or structure where the service enters. The main disconnecting means for each building or structure served must be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. Either location is acceptable. The disconnect must be located within sight of the panel for panels with greater than 6 disconnects or 42 overcurrent protective devices. For service disconnects located outside of the building or structure, a readily accessible means of opening the service disconnect must be provided at the service location. National Electrical Code Section 225.30 addresses the disconnection of grounded conductors. Regarding panel boards, National Electrical Code Section 225.30b states that where a panel board is supplied through a service disconnecting means located outdoors or in another building from the panel board or is supplied by any other arrangement where the disconnecting means is not readily accessible from within or adjacent to the building or structure that the panel board supplies, a disconnecting means must be provided for each supply-side conductor at the panel board. This disconnecting means must be capable of being locked in the open position if it is accessible to other than qualified persons. Let's delve deeper into the specifics of these requirements. Firstly, the requirement for a readily accessible disconnect emphasizes the importance of having a means to quickly de-energize the electrical system in case of emergencies or for maintenance purposes. Readily accessible means that the disconnect should be easily reachable without the need for tools, ladders, or other obstructions. Secondly, the rating of the disconnect being not less than the service amperage is crucial to ensure that the disconnect can handle the full load of the electrical service without overheating or failing. The service amperage is the maximum current that the electrical service is designed to supply. Thirdly, the location of the main disconnecting means is specified to be either outside the building or structure or inside nearest the point of entrance of the service conductors. This provides flexibility in installation while ensuring that the disconnect is readily accessible to authorized personnel. The option of placing the disconnect outside the building is particularly useful in situations where access to the inside of the building may be restricted or inconvenient. Fourthly, the requirement for the disconnect to be within sight of the panel for panels with greater than 6 disconnects or 42 overcurrent protective devices is intended to prevent accidental energization of the panel while work is being performed on it. Being within sight means that the disconnect must be visible from the panel, allowing the person working on the panel to verify that the disconnect is in the off position before commencing any work. Fifthly, the provision for a readily accessible means of opening the service disconnect at the service location for disconnects located outside the building or structure is an additional safety measure. This ensures that even if the main disconnect is located some distance away from the service entrance, there is still a way to quickly de-energize the system at the point where it enters the building. Lastly, National Electrical Code Section 225.30b addresses the specific case of panel boards that are supplied through a service disconnecting means located outdoors or in another building or that are supplied by any other arrangement where the disconnecting means is not readily accessible from within or adjacent to the building or structure that the panel board supplies. In these situations, a disconnecting means must be provided for each supply-side conductor at the panel board. This is to ensure that the panel board can be completely de-energized even if the main service disconnect is located remotely. The requirement that this disconnecting means be capable of being locked in the open position if it is accessible to other than qualified persons is a further safety measure to prevent unauthorized persons from energizing the panel board while work is being performed on it. Qualified persons are those who have the skills and knowledge related to the construction and operation of electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. In summary, the National Electrical Code mandates specific requirements for disconnects in residential electrical systems to ensure safety and accessibility. These requirements cover the rating, location, and accessibility of disconnects, as well as the need for disconnects at panel boards in certain situations. Compliance with these requirements is essential to protect people and property from electrical hazards. Let's consider some practical examples to illustrate these requirements. Example 1: a single family home with a 200 amp service. The service entrance is located on the outside of the house. In this case, a 200 amp rated disconnect must be installed at the service entrance. The disconnect must be readily accessible, meaning that it should be located in a place where it can be easily reached without the need for tools or ladders. Example 2: a multi-family dwelling with multiple electrical panels. Each panel is supplied by a separate service disconnecting means located in a common area. In this case, each service disconnecting means must be rated not less than the service amperage for the panel that it supplies. The disconnects must be readily accessible to authorized personnel. Example 3: a detached garage that is supplied by a feeder from the main house. The disconnecting means for the feeder is located in the main house. In this case, a disconnecting means must be provided for each supply side conductor at the panel board in the garage. This disconnecting means must be capable of being locked in the open position if it is accessible to other than qualified persons. These examples illustrate the importance of understanding and complying with the National Electrical Code requirements for disconnects in residential electrical systems. By following these requirements, we can ensure that electrical systems are safe and accessible for both authorized personnel and homeowners. It is always recommended to consult with a qualified electrician to ensure that electrical installations meet all applicable codes and standards. Failure to comply with these requirements can result in serious electrical hazards, including shock, electrocution, and fire. Therefore, it is crucial to take these requirements seriously and to ensure that all electrical work is performed by qualified professionals. In addition to the specific requirements for disconnects, there are also general safety precautions that should be followed when working with electrical systems. These precautions include always energizing the circuit before working on it, using insulated tools, wearing appropriate personal protective equipment, and never working on electrical systems when wet or damp. By following these safety precautions, we can minimize the risk of electrical accidents and ensure that electrical work is performed safely and effectively. Furthermore, it is important to note that the National Electrical Code is not a static document. It is updated every 3 years to reflect changes in technology and best practices. Therefore, it is essential to stay up to date on the latest edition of the National Electrical Code to ensure that electrical installations meet the most current standards. Continuing education courses and professional development opportunities are available to help electricians and other electrical professionals stay informed about the latest changes to the National Electrical Code. By investing in continuing education, electrical professionals can enhance their knowledge and skills and provide the highest quality electrical services to their clients. In conclusion, the National Electrical Code requirements for disconnects in residential electrical systems are designed to protect people and property from electrical hazards. These requirements cover the rating, location, and accessibility of disconnects, as well as the need for disconnects at panel boards in certain situations. Compliance with these requirements is essential to ensure that electrical systems are safe and accessible for both authorized personnel and homeowners. By following these requirements and general safety precautions, we can minimize the risk of electrical accidents and ensure that electrical work is performed safely and effectively. And also do not forget that the 2017 National Electrical Code Section 225.30 states that for one-family dwellings, the disconnecting means must have a rating of not less than the load calculated in accordance with Part 220. It should also be suitable for use as service equipment. The National Electrical Code further states that a disconnecting means must be installed at each building or structure to disconnect all ungrounded conductors. In summary, the readily accessible disconnect, amperage rating equal to or greater than the service load, location at service entrance either inside or outside, visibility requirements for large panels, external disconnect provisions, and panel board disconnects with lockable features collectively constitute a safety net to prevent electrical hazards. Regular inspections, strict adherence to the NEC, and reliance on qualified personnel will ensure that electrical systems remain safe, reliable, and compliant with the most up-to-date safety standards. It's also good to talk about overcurrent protection in addition to disconnecting means. Overcurrent protection devices such as circuit breakers and fuses are vital in residential panels. Circuit breakers trip when the current exceeds the breaker's rated amperage, interrupting the circuit and preventing overheating and potential fires. Fuses, similar to circuit breakers, melt and break the circuit when the current exceeds their rating. Understanding the ampere interrupt capacity, or AIC, of these devices is crucial. The AIC rating indicates the maximum fault current the device can safely interrupt. In residential applications, the AIC rating of circuit breakers and fuses must be sufficient to handle the available fault current at the service entrance. Proper selection ensures that in the event of a short circuit or ground fault, the overcurrent protection device can safely clear the fault without causing damage or endangering the system. Grounding and bonding are also critical components of residential electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. Bonding connects non-current carrying metal parts such as conduit, enclosures, and equipment grounding conductors to create an electrically conductive path. This ensures that all metal parts are at the same potential, minimizing the risk of electric shock. Proper grounding and bonding are essential for creating a safe electrical environment in residential buildings, protecting occupants from electrical hazards. Also remember that surge protection is an important consideration for residential electrical panels. Surge protective devices, or SPDs, protect sensitive electronic equipment from voltage spikes caused by lightning, utility switching, and other transient events. SPD divert excess voltage to ground, preventing damage to appliances, electronics, and other devices connected to the electrical system. Installing SPD at the service entrance and at individual branch circuits can provide comprehensive surge protection for the entire home. This protects valuable electronics and appliances from costly damage due to voltage surges. Arc fault circuit interrupters, or SIs, are another essential safety device for residential electrical panels. SIs detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors, creating heat and potentially igniting nearby combustible materials. SIs interrupt the circuit when an arc fault is detected, preventing the arc from escalating into a fire. The NEC requires SIs in branch circuits supplying bedrooms, living rooms, and other areas where arc faults are more likely to occur. Regular testing of SIs is important to ensure they are functioning properly and providing reliable protection against arc faults. Finally, tamper-resistant receptacles are an important safety feature, especially in homes with young children. Tamper-resistant receptacles have internal shutters that prevent foreign objects from being inserted into the slot. This reduces the risk of electric shock from children inserting objects such as paper clips or keys into the receptacles. The NEC requires tamper-resistant receptacles in all areas of dwelling units, providing an added layer of safety for families with young children. This is a basic rundown on some of the electrical safety requirements for electrical panels in residential applications.